Hi, today I'm going to discuss sensors and transducers. And at the end of this module, you should be able to understand and describe sensors and transducers. Second, discuss how to choose a sensor. And finally, differentiate the requirements for sensors and transducers. Now, we live in an analog world with digital means of communication and control mechanical objects with electrical signals. And this is possible because of the devices like sensors and transducers, which help us in converting the data or information from one domain to another. No? A regular setup or a common setup of sensors and actuator is given here, wherein the microphone acts as the sensor and it's being fed to the controller, which is the amplifier, and connected to the actuator, which is the loudspeaker. Now, measurement is an important subsystem in any major system. Now, we discussed this from our last module, whether it may be a mechanical system or an electronic system. Now, a measurement system consists of sensors, actuators, transducers, and signal processing devices. And the use of these elements and devices is not limited to measuring systems. These are also used in the systems which perform specific tasks to communicate with the real world. The communication can be anything like reading the status of a signal from a switch or to trigger a particular output to light up an LED. Now let's discuss the common definitions of the term sensors and transducers. So basically, the words sensors and transducers are widely used in association with measurement systems. The sensor is an element that produces signals relating to the quantity that is being measured. And according to Instrument Society of America, a sensor is a device that provides usable output in response to a specified quantity which is measured. So the word sensor is derived from the original meaning, which means to perceive. In simple terms, a sensor is actually a device that detects changes and events in a physical stimulus, and it provides a corresponding output signal that can be measured or can be recorded, for example. So the output signal can be any measurable signal and can be generally an electrical quantity, as an example. Basically, sensors are devices that perform input functions in a system as they sense the changes in a quantity. Now, coming from the word sensor, they sense the changes in a quantity. Well, the best example of a sensor is a mercury thermometer, wherein the quantity that is being measured is heat or temperature, and the measured temperature is converted to a readable value on the calibrated glass tube based on the expansion and contraction of liquid mercury. Now, actuators are devices that work opposite to sensors. A sensor converts a physical event into an electrical signal, whereas an actuator converts electrical signal into a physical event. When sensors are used at input of a system, actuators are used to perform output function in a system as they control an external device. So basically, the transducers are the devices that convert the energy in one form into another form. So generally, the energy is in the form of a signal. And transducer is a term collectively used for both sensors and actuators. Now let's try to discuss about the different criteria to choose a sensor. Now, as you can see from here, there are many criteria to choose whenever we have to choose sensor, and the following are certain features that are considered when choosing a sensor. For example, the type of sensing. So in the type of sensing, the parameter that is being sensed is like, for example, like temperature or pressure, the type of sensing. In the operating principle, so we're talking about the principle of operation of the sensor. No? How is the sensor being operated? And in terms of power consumption, so this is very important because we're talking about the power consumed by the sensor, which we should know that it plays an important role in defining the total power of the system. Okay? So definitely power consumption should be a criteria when choosing a sensor. Another is what we call the accuracy. So the accuracy of the sensor is also a very important factor. Actually, it's a key factor in selecting a sensor. Another one is the environmental conditions. So the conditions in which the sensor is being used will be a factor in choosing the quality of a sensor. For example, are you using it in a cold weather condition or a warm weather? Are you going to use it in the mountain, in the sea, etc., etc.? So the environmental condition is a very important factor in choosing the quality of the sensor that we're going to use. Another one is the cost. No? Depending on the cost of the application, for example, a low-cost sensor or high-cost sensor can be used. Okay? And then we have the resolution and the range, which is very important. Okay? Why? Because the smallest value that can be sensed and the limit of measurement are important. Okay? Finally, we have the final criteria, which is the calibration and the repeatability. No? The change of values with time and ability to repeat measurements under similar conditions. So these are all the criteria that we will be considering whenever we want to choose a sensor. Okay? Now, the following are the basic requirements of a sensor or transducer. Okay? And the basic requirements are the following. So we have the range. So when we talk about the range, so we're talking about the limits of the input in which it can vary. Okay? So in case of a temperature measurement, for example, a thermocouple can have a range of 25 to 250 degrees Celsius, as an example. Another requirements of a sensor and transducer is the accuracy. Now we're talking about the degree of exactness between the actual measurement and the true value. Actually, accuracy is expressed as percentage of full range output. Okay? And then we have the sensitivity. So when we talk about sensitivity, sensitivity is a relationship between the input physical signal and the output electrical signal, and it is the ratio of the change in the output of the sensor to unit change in the input value that causes change in the output. So that's basically the sensitivity. Now when we talk about stability, it is the ability of the sensor to produce the same output for constant input over a period of time. So that's what we call the stability, meaning it should when you for example when you're using a sensor, it should definitely had the ability to produce the same output constantly for a very long period of time. Okay, so the repeatability here is the ability of the sensor to produce the same output for different applications with same input value. So that means we have the same input value, but we can use those values to produce same output for different applications. Okay? Now the response time here is the speed of change in output on a stepwise change in input. Okay? While the linearity that is given here is specified in terms of the percentage of nonlinearity. And nonlinearity in terms of sensors and transducers are an indication of deviation of curve of actual measurement from the curve of the ideal measurement. Now, the ruggedness mentioned here, which is also a basic requirement, is a measure of the durability when the sensor is used under extreme operating conditions. For example, you are using your sensor and your transducer in very extreme weather or temperature, very hot temperature. No? Is your sensor or transducer can be able to cope up with that extreme operating condition? So if it is not, then the quality or the percentage of the ruggedness of that sensor is definitely low. So in choosing a sensor and transducer, it's one of the basic requirements that we should be able to have whenever we are definitely choosing a sensor or a transducer. Now, the hysteresis mentioned there is defined as the maximum difference in output at any measurable value within the sensor's specified range. Within the sensor's specified range, no? When approaching the point first with increasing and then with decreasing the input parameter. Actually, hysteresis is a characteristic that a transducer has in being able to repeat its functionality faithfully when used in the opposite direction of operation. Alright, so these are the basic requirements of the sensors and transducers. Now let's go with the classification of the sensors. How do we classify the sensors? Actually, the scheme of classifying sensors can range from very simple to very complex, and the stimulus that is being sensed is a very important factor in this classification. Some of the stimuli are acoustic, electrical, magnetic, thermal, mechanical, and optical. So when we say acoustic or acoustic, so we're talking about waves, spectrum, and wave velocity. So when we're talking about electric, we're talking about the current, the charge, and the potential voltage, for example. Okay? Potential, and then we're talking about some electric field, permittivity, and conductivity. So when we talk about magnetic, so for example, we are dealing with magnetic field, magnetic flux, and permeability. Okay? And then of course thermal describes the temperature, specific heat, and thermal conductivity. Okay? In terms of mechanical, there are plenty of things about mechanical. We're talking about the position, acceleration, the force, the pressure, stress, strain. We're talking about mass, density, momentum, torque, shape, orientation, roughness, stiffness, compliance, crystallinity, and structural. Okay? And finally, for optical, so when we say optical, it's almost similar to acoustic. So we're talking about waves also, the wave velocity, the refractive index, the reflectivity, okay, absorption, and emissivity. So those are the things associated with this stimuli. Okay, so the sensors, actually, the sensors conversion phenomenon is also an important factor in classification of sensors, and some of the conversion phenomena are magneto-electric, thermoelectric, and photoelectric. And based on the applications of sensors, because this classification is based on the stimuli, but we also have a classification based on the application of sensors. Now, for example, these are some of the common applications, and we can classify the sensors according to each, no? And all of the sensors can be classified into actually two types based on the power or signal requirement, no? And they are active sensors and passive sensors. So let's start to discuss about the application wherein we are talking about displacement, position, and proximity sensors, no? So we're talking about, when we talk about displacement, position, and proximity sensors, we're talking about the following, no? We have resistive element or potentiometer. Those are some example. So you can search more about this type of sensor, and I believe you are familiar with potentiometer, no? This is a type of a resistor. And then another one is the capacitive elements, 3 strain gauge element, and then number 4, inductive proximity sensors are also categorized when we're talking about applications as displacement and position and proximity sensors. And then we have the eddy current proximity sensors. We also have differential transformers, optical encoders, Hall effect sensors, pneumatic sensors, proximity switches, and rotary encoders. So if you want to know more about the details of this applications or examples of sensors and transducers, you can search for it, but they are actually classified according to the application of displacement, position, and proximity sensors. Another type is what we call the temperature sensors. Okay, so from the temperature sensors, we have examples such as thermistors, thermocouple, bimetallic strips, resistance temperature detectors, and we have the thermostat. So these are examples of temperature sensors that basically deals with the application covering temperature, no? The hotness and coldness of the environment, of a certain chemical or a certain matter, for example. Okay. Another example of an application is what we call the light sensor. In light sensors, we are dealing with examples such as photodiode, phototransistor, and light-dependent resistor. So basically, these are sensors that that act depending on the lightness and the darkness of the environment. For example, no. For example, if you see some, have you noticed the street lights? There are no switches actually, no. So they are using light sensors or photodiode or phototransistors that whenever the sun goes down and there's no light coming out, the photodiode or phototransistor or light dependent resistors activates the function of switching on the lights from the street lights, no. And then in the morning, when the sun rises up, so it activates the off function of the street light. So there's no one who is actually turning on and turning off the lights. It's automatic because they use light sensors to do that. Okay. Another one is the application in terms of velocity and motion. No, we're talking about the speed, for example, no. So we have, for example, pyroelectric sensors, and then we have the tacho generator, and then the incremental encoder, no. This seems like a digital sensor. Okay, so these are sensors responsible for measuring the speed, no, and the slowness and the fastness of motion, no. We're talking about motions. So it also indicates, for example, in some applications, you can see that whenever there is a burglar, no, or there is a thief entering a vicinity, a certain place, and the sensors are sensing movements inside that vicinity, then the alarm will be triggered. Okay, so there's no one to do that, but it is actually the sensors who sense that there is actually a movement or a motion. Okay, so those are some simple examples of velocity and motion sensors. Another one is what we call the fluid pressure, no, applications. And we have some examples here, such as diaphragm pressure gauge, tactile sensor, piezoelectric sensors, and then the capsules, the bellows, and pressure tubes. No, I've seen many project designs that that they have used or applied piezoelectric sensors, no, and these sensors uh, sense something and measure something, and then it is used and applied in their system so that it interacts with the environment and the machine or the project that they have created, or the prototype. I mean, I'm talking about the prototype. They use it to be able to actuate something on the environment, right? So those are some of the examples. Another application is the liquid flow and the level. No? So this is different from fluid pressure. This is somehow related to liquid flow and the level of the liquid. Okay, so we have what we call the turbine meter, or the orifice plate and venturi tube. So basically, these are commonly used um, in dams and in watersheds, for example, wherein they want to capture the flow of the water in the river, or for example in a dam, etc., etc. Okay, another one is what we call the infrared sensor. This is very common nowadays, right? So infrared sensors are are made up of a transmitter and a receiver pair, basically. So there are many applications of this nowadays. Okay, um, the the RFID is an example of this, no, the infrared sensor technology. Okay, and then we have, by application, we have the force. So we are measuring the strain gauge or the load cell. So these are also called sensors, measuring the strength of materials, so using the force. And then we have the touch sensors, the touch sensors such as the resistive touch sensors and the capacitive touch sensors. So basically, the touch screen that we are using nowadays in our iPads, in our phone, in our computers. So basically, it's made up of resistive and capacitive touch sensors. No, that it actuates once we touch the surface of that glass. No, and then it actuates into something. It converts the touch that we have applied on the surface. It converts something into something. Okay, so it actually um, is used to interface to our uh, devices. Okay, so those are example of sensors. And then we have the ultraviolet sensors. No, we have examples such as ultraviolet light detector, the photo stability sensors, the ultraviolet photo tubes, and then the germicidal ultraviolet detectors. So nowadays we are familiar with this with the usage of this UV sensors. No, in many water stations they have the UV sensor, which is used to to kill, at the final stage of the filtering, the final state which is to use the UV light to kill the remaining particles that are not appropriate for drinking the water. Okay, so those are some examples. There are plenty of examples that you can search. If you want to know more about it, you can search it from the internet. Okay, so all these sensors can be classified into many types, no, based on the applications and based on the power or signal requirement, no. So basically they can be considered as active sensors and passive sensors, no. And in order to operate active sensors, it requires power signal from an external source, no. And this signal is called an excitation signal, and based on this excitation signal, the sensor produces output. Now, like for example, the strain gauge, no, the strain gauge for the force. Okay, this strain gauge here is an example of an active sensor. It is a pressure-sensitive resistive bridge network and doesn't produce the output electrical signal on its own. But the amount of force applied can be measured by relating it to the resistance of the network. And the resistance can be by passing current through it, and the current acts as the excitation signal. Now, in contrast, the passive sensors directly produce the output electrical signal in response to the input stimulus, and all the power required by a passive sensor is obtained from the measurand, no? So an example of this is what we call the thermocouple, no? Which is an example of the temperature sensor and also considered as a passive sensor. Okay? Now, we have here the commonly used sensors and transducers. Okay? Some of the most commonly used sensors and transducers for different stimuli, which is the quantity to be measured, are the following, no? For example, for sensing light. For sensing light, the input devices or sensors are photodiode. Okay? As an example, we also have phototransistor and some of the light-dependent resistor and solar cells. And the output devices or actuators are sometimes LEDs, displays, lamps, and fiber optics. For sensing temperature, the sensors are thermistor, okay? And then we have thermocouple. We also have resistance temperature detectors and thermostat. And the actuators are the heaters. So we're talking about some examples of the sensors and their transducers or actuators. For sensing position, the input devices are, for example, potentiometer, okay, potentiometer, and then another example is aside from potentiometer, we have proximity sensor and differential transformer. And the output devices are motor. It can be a motor and a panel meter, no, sensing the position. Okay. Another one is what we call the sensing pressure, for sensing pressure, where the sensors are strain gauge and load cell, no? You have seen from the examples a while ago. The actuators are lifts and jacks, no? And electromagnetic vibrations. Another one is what we call for sensing sound. Okay, so the input devices are microphones. So this is the most common example, and the output devices are either a loudspeaker or buzzers. Okay. Now for sensing speed, The sensors used are tacho generator and Doppler effect sensors, and the actuators are motors and brakes. These are used now, commonly used nowadays for um, self-driving cars. Now they are using sensing speed sensors for uh, actuating the motor and then actuating the brakes of the vehicle. Okay, so this illustration here that you can see is a simple system using transducer. You can see it's made up of a um, microphone, and then we have an amplifier and the sensor or the device with input function, okay, is the microphone, and then it senses the sound signals, as you can see from here, and transform them into electrical signals. Once the signal is transformed into electrical signal, the amplifier receives these electrical signals and amplifies their strength. Now the actuator, as you can see from the illustration, okay, the actuator here is what we call the output device. Okay, so for the output device we have the loudspeaker, no, which receives the amplified electrical signal from the amplifier and converts it back into sound signals, but with more reach. Okay, so basically this is an example of a simple system using the transducer. Now we also have what we call analog sensors. Okay, and analog sensors produce continuously varying output signals over a range of values, and usually the output signal is voltage, and this output signal is proportional to the measurand. No? The quantity that is being measured, like speed, temperature, pressure, strain, etc., are all continuous in nature, and hence they are analog quantities. Now, an example of this is a cadmium sulfide cell or CDS cell, okay, which is used to measure the intensity of light, okay, and then the resistance of this example, the cadmium sulfide cell, varies according to the intensity of the the distance, okay, of the light incident on it, no? According to the intensity of the light, okay. So this is an example of what we call the um, analog sensor. No? Now, when connected to a voltage divider network, for example, the change in resistance can be observed through varying output voltage. And as an example, in this example, no, we have a thermocouple, or a thermometer is considered to be an example of an analog sensor. No? The output of an analog sensor, as you can see from here, can vary between 0 to 5 volts. No? So you can see from here the thermocouple acts as a sensor. No? So this setup is used to measure the temperature of the liquid in the container using a thermocouple. So if you want to measure the temperature of the liquid in a particular container, you can use a thermocouple for that. Okay. Another example, okay, this is the output signal, no, of the analog sensor. So you can see that the output of an analog sensor, based from the image here, the output of the analog signal that you can see from here, can be depicted, no, using the illustration, and you can see that the output of this particular uh, analog sensor tends to change smoothly, no, and continuously over time. Hence, the response time and accuracy of circuits employing analog sensor is slow and less, no? And in order to use these signals in a microcontroller-based system, analog to digital converters can be used. Now, analog sensors generally require an external power supply and amplification of some form to produce appropriate output signals. Op-amps are very useful in providing amplification and filtering. Okay? Now, aside from analog sensors, we also have what we call digital sensors. No? A digital sensor produces discrete digital signals. The output of a digital sensor has only two states, namely on and off. On is logic 1 and off is logic 0. And a push button switch is the best example of a digital sensor. And in this case, the switch has only two possible states. Either it is on when pushed, or it is off when released or not pushed. Okay? So, as an example, the following setup uses a light sensor to measure the speed and produces a digital signal. No? Here you will see in the setup, the rotating discs, okay, is connected to the shaft or the shaft of a motor and has a number of transparent slots. No? And the light sensor, okay, the light sensor captures the presence or absence of the light and sends logic 1 or logic 0 signal according to the counter. Okay, so the counter, what it does is that it the counter displays the speed of the discs. Okay, it displays the speed of the disc, and the accuracy can be increased by increasing the transparent slots on the disc as it allows more counts over the same amount of time. Now, in general, the accuracy of this example of a digital sensor is very high when compared to an analog sensor. No? And the accuracy depends on the number of bits that are used to represent the measurand. Higher the number, or the higher the number of bits, the greater is the accuracy. All right. So basically, that's the concept of sensors and transducers, and I do hope that you are going to research on some of the examples of sensors that were given. And if you do have some questions and inquiries pertaining this lecture, you are free to message me using our public chat, or you can use your microphone and ask me personally. Okay, so thank you for listening. Thank you for your attention.